Hello and welcome to this microlearning. In this video we will focus on the buffer level management of demand-driven material requirements planning. My name is John Oxenby and I'm a solution advisor with SAP. Our agenda for today is keywords followed by a system demo. First keyword is product classification. In demand-driven MRP, products are systematically evaluated based on a set of criteria. These are: value is represented by the A, B and C classification. It is the percentage ratio of price and consumption over the time period compared to the total value of the parts consumed in the plant. Variability is represented by X, Y and Z and is based on the variation of usage over the time period calculated on goods issue value. Frequency used in manufacturing is P, Q and R, where P is high frequency. This is simply how many different times a product is part of a bill of material. We will also classify the products based on their decoupled lead time. This is known as the E, F and G classification. This classification is typically used together with the procurement type for a product or a component. Lead time uses days as its unit of measure, and it is calculated based on the transactional data which is within the horizon decided. An example would be purchasing lead time would be the time between the issue of the purchase order and the time of the goods receipt. Let's look at buffer level management in S/4HANA. We have a 3-level bill of material. There are 2 finished goods which use the semi-finished good S201. S201 is in turn using R302 and S301 during the manufacturing process. S301 is produced using the raw material R401. We can also see that we have 2 buffers. The first buffer is placed at S201. The second buffer is placed at R401. As you will know from the keyword section, the buffers are strategically positioned based on value, volatility, bill of material usage and lead time. We begin the demo by reviewing the buffer positioning. There are 2 materials which are under our responsibility, R401 and S201. We can see that both materials are planned with DDMRP, including the classification data of each material. Next, it's time to review our raw material. In the buffer analysis, again we can see all the characteristics of our material, including the lead time and the number of bill of materials it is used in. We can also see the immediate parent and any subsequent materials in which our raw material would be part of. This information can also be viewed graphically. Let's look at the product flow. If we look from right to left, we can see that our raw material is a component of 2 finished products, which both uses the semi-finished good S201. Looking to our left, we can see that our raw material is part of an other semi-finished good, S301, which is a component of S201. We have a graphical view of the product flow of our manufacturing process. We highlight the materials in this chain, which are planned using DDMRP. From this screen we can also view details on the material. As well as choosing to remove the buffer on our material or communicate with our colleagues, for example via email, the recipient will then get the same filter criteria which was used when sending the email, making communication easier and more efficient. Next step is to schedule the buffer proposal calculation for our materials. We create our job and schedule it to run immediately. Our scope of planning will be S201 and R401 for our American plant named 1710. Next, we decide that we want to retain manual control instead of immediately accepting the proposed changes. When making the run, we also want the decoupled lead time to be recalculated based on the actual transactions which have occurred within our horizon. We can also make a choice if we want our job to have a fixed or rolling time interval when calculating the average daily usage. Finally, we will review the proposed changes to our materials. On the screen we have the historical information of buffer levels as well as the expected future demands. We also have the proposed changes, which are the foundation for adjusting. Let's review the details before adopting the changes. We select material S201. We can review the buffer levels. The top of the red zone is the safety stock level. The top of the yellow zone is the reorder point, and the top of the green zone is the maximum stock level. If you should see a blue layer, then it means that you have exceeded the maximum desired stock level. Average daily use is also shown. The future consumption shown comes from requirements which can be known production orders and sales orders. The decoupled lead time shows the longest replenishment lead time for our semi-finished material. The classification data shows the current classification on value, volatility, bill of material usage and lead time, as well as the suggested future changes. Keep in mind, when we talk about BOM usage, we refer to the number of times a material is used in production, not the type of BOM. What is high, medium and low is configurable according to your industry needs. Lastly, we choose to adopt the changes. We have now discussed the product classification, which is the basis for buffer level management within DDMRP, reviewed the proposed changes and decided to adopt our planning. Additional information and theoretical and practical examples on demand-driven material requirements planning can be found at the Demand Driven Institute. Thank you for listening.